Hello. In this video, we discuss the mutual inductance of a pair of solenoid. This is the pair of solenoid I consider, with one which is of small area and the other one is with the larger turn area. Okay. Now, the current is flowing through the outer coil, suppose. When the current is flowing through the outer coil, there will be a magnetic field produced inside, and in that magnetic field, the inner coil turn areas are coming. Therefore, there is a flux linkage with the inner coil due to the current flowing through the outer coil. Now let us consider the flux phi linked with the inner coil will be directly proportional to the current I flowing through the outer coil. Okay? Then flux phi is equal to M into I. Equation 1. M is the mutual inductance, that is what we want to find. Now, the same thing if I consider in terms of field and area, flux phi is equal to magnetic field produced by the outer coil into total area of the inner coil. So let me say that N1 is the number of turns of the inner coil. This is having N1 turns. A is the area of the inner coil. This area. Okay. Then flux phi will be equal to B, which is mu 0 N2 into N2 by L2 into I. This is the field inside a solenoid without considering the end correction. Then into N1 into A, where N2 is the number of turns of the outer coil. N2 is the number of turns of the outer coil. Then phi 2. So here what is L2? L2 is the length of the outer coil. Now rearrange it, you get mu 0 N1 into N2 into A into I divided by L2, you get. So if I take this as equation number 2, then 1 and 2 you can compare and you get M is equal to M means current flowing through the outer coil. Okay, M2. Let me say M2, current flowing through the outer coil will be equal to mu 0 N1 into N2 into A by L2. When the current is flowing through the outer coil with the length L2. Okay? So we found that the mutual inductance depends on number of turns of this coil and the area of the coil inside. Okay? Now let us assume the special case that suppose this current I is flowing through the inner coil. When the current I flows through the inner solenoid, there will be a magnetic field produced inside this inner coil. Right? There will be a magnetic field produced in the inner coil. Within that magnetic field, a part of the outer coil area is linked. So there will be a flux linkage with a part of the outer coil area with the field produced inside the inner coil. Understood? Then, if you consider that case again, let us start with flux phi linked with the outer coil directly proportional to the current flowing through the inner coil. Then phi is equal to m into I, where m is the mutual inductance, and here let me take this m to be m1 because the current is flowing through the inner coil. Then the same thing if I assume here, that is in terms of field and area, let us see what happens. Flux phi is equal to magnetic field produced inside the inner coil into total area of the outer coil linking with the field. So if this is the total area of the outer coil, right? But only this much is of that coil area, only this much part of the outer coil area is now linking with the magnetic field. So you have to consider only this much area of the outer coil. That means N, what is N? Here N is the number of turns of the outer coil, that is N2 outer coil into A. A is the same as the area of the inner coil because this same area of the outer coil is coming inside the magnetic field. Okay? Then flux phi equal to B, magnetic field inside the inner coil will be equal to mu 0 N1 by L1 into I into N2 into A, where L1 is the length of the inner coil and N1 is the number of turns of the inner coil. And finally what you get is that phi equal to mu 0 N1 into N2 into A into I divided by L1 as your equation number 2. Now when you compare this and this one, equation 1 and 2 for the current flowing through the inner coil, you get M1 is equal to 1 for current flowing through the inner coil will be equal to mu 0 N1 into N2 into A by L1. So only difference is that length. So if the current is flowing through the inner coil, length of the inner coil is coming here. If the current flowing through the outer coil, or length of the outer coil is coming here. But when you construct a pair of coils like this for mutual induction, practically this L1 will be equal to L2. Suppose L1 is equal to L2, then you can find that, let us assume this as L, then the mutual inductance M1 is found to be equal to M2. So if this condition is satisfied, if that condition is satisfied for the given pair of coils, mu 0 N1 N2 A by L is the mutual induction you can have. So for the given pair of coils, if the solenoids are of the same length, then the mutual inductance remains the same for both, whether irrespective of the current, whether it is flowing through the outer coil or through the inner coil.